Welcome back. In this session, we will see the performance of 200 kg vehicle with 3 kilowatt golf cart DC series motor. So, I have one DC series motor which is specially built for the golf cart. It is very old golf cart. This golf cart electric vehicle motor is manufactured by Emerald Electric Vehicle Corporation. So we are having the data of rated power, rated voltage, rated current and rated speed available with us, and the data of armature resistance, armature inductance, field resistance, field inductance and mutual inductance were calculated experimentally by the Pawak sir and Oves sir. So thanks to the Pawak sir and Oves sir for providing this data. They belongs to also assistant professor at the Marwadi University, Rajkot. So thanks to the Marwadi University also for providing this data and this motor. So if we are having the 3 kilowatt 48 volts, so this is importance. Now we are having the low voltage and high ampere. Its rated current is 72 ampere. So rated current is 72 ampere and voltage is 48 volts. So low volt and high ampere motor specially designed for the electric vehicle application, and this is the DC series motor. So we will get the high starting torque. So starting performance can be improved, right? So here we are having the data sheet. You can check it. The armature resistance 0.18, the inductance 0.68 millihenry, field resistance 0.1 ohm around, field inductance 2.8 millihenry and mutual inductance 6 millihenry. So in case of DC shunt motor, the constant back EMF is constant, does not depend upon the current because field current were constant. But in this case field current is also changing, so we will also have the high starting torque and this different effect. So here simply I have applied the 48 volt to the DC motor armature winding. You also need to observe your connections are changed. So it is positive terminal is going to positive of the armature and negative of the armature is connected to the positive of the field winding, and negative of the field winding goes back to the negative of the DC supply. So this way we have formed the DC series connection for the field winding. So whenever you observe the data sheet, if it is the field DC series motor, the resistance of the field winding will be very less always. So note it down so we can have idea. So only we are supplying the 48 volt, and because we are having the higher ampere, so winding is designed to allow the higher ampere, so that this motor will give the higher starting torque because series motor, and we will discuss the different performance. So let first simulate it and we will observe the starting peak current goes very high and it is reducing, and we are achieving the higher steady state speed also with compared to 3.67 kilowatt DC motor, which is 5 HP DC motor that we discussed earlier, and this is 3 kilowatt DC series motor. So shunt motor and series motor comparison can also be done. And if we check the speed response, acceleration response, so maximum speed is high, but here also we can have the higher acceleration starting torque but here current is too much high. So when we limit the starting current, as we discussed the closed loop operation with the hysteresis current control, one can also go for the PID controller. So we have not discussed here the different control strategies. So to simplify it, we restrict it to the hysteresis controller. So same hysteresis controller can be implemented here to restrict the starting current beyond the limit, and later on you can see for the steady state speed current value is less, around 70 ampere. And and speed control can be achieved by the same way, controlling the reference current, or in case of PID controller, controlling the duty cycle of PWM to control the average voltage. So if you implement the PWM, that can be analyzed by simply replacing the voltage source by the control voltage source and controlling the average VDC. So we can have some estimated idea about the performance when we control the voltage, but those belong to power electronics and electrical engineering and drives. They wanted to implement the power electronics converter and check their performance also. So this is how we can implement. Now our model is ready, then we can implement any specific motor to check the performance of our vehicle. If this specific motor we connect with the vehicle, then how it will perform in terms of the acceleration and maximum speed.